Now, there are also, I just mentioned these two right over here. And the second, I'm just going to go with the worst one on this list, on this chart for now. O of n squared. Now, what does that look like in, let's say, in an example? Let's say you have a class of students and you want each and every student to shake hands with each and every other student. Now, if you have 10 students, that would be 100 handshakes. If you have 100 students, it would be like 10,000 handshakes. So each and every element needs to interact with each and every element in the input data. Now, as you can see, as the scale, the size of the input data scales, also the time it requires to go through each and every step will scale proportionally. Think of, if you are coming from a programming background, think of a for loop within a for loop. So you just need to go through the array and each and every element, and for each and every element, you just go through the array once more. Now, this is really bad. That's why I added it as red. Now, there is this also on O of n log n. Now, this is not that optional performant as O of n, which also, like, if you just want to go through 1 million elements, that's also really time intensive. But we are going to use O of n log n. It's coming from O of log n, but we're just going to multiply it by n. And that's why it sits right over here. Now, I'm not going to go deeper this time right over here. We're going to take it in another lesson or multiple lessons when we are going to talk about sorting, because usually worst case scenario of time complexity for sorting algorithms is O of n log n.